Hello everyone, my name is VIKNESWARAN and we are from Group 2. So today we're going to present about XRF spectrometer.
Hello guys, I am Sri and let's talk about our XRF spectrometer. So let's first look at the table of contents where I'll be explaining about the function of the spectrometer, the working principle of the spectrometer, the key components involved and the examples of models in market. So let's begin with the XRF spectrometer and its functions. XRF or X-ray fluorescence is a non-destructive analytical technique used to determine the elemental compositions of materials. XRF analyzers determine the chemistry of a sample by measuring the fluorescence or secondary X-ray emitted from a sample when it is excited by a primary X-ray source. Each of the elements present in a sample produces a set of characteristic fluorescent X-rays, a fingerprint that is unique for that specific element, which is why XRF spectrometry is an excellent technology for qualitative and quantitative analysis of material composition. Now, let's look at the working principle of the XRF spectrometer. So, initially, a solid or a liquid sample is irradiated with high energy X-rays from a controlled X-ray tube. When an atom in the sample is struck with an X-ray of sufficient energy, which is greater than the atom's K or L shell binding energy, an electron from one of the atom's inner orbital shells is dislodged. The atom then regains stability, filling the vacancy left in the inner orbital shell with an electron from one of the atom's higher energy orbital shells. The electron drops to the lower energy state by releasing a fluorescent X-ray. The energy of this X-ray is equal to the specific difference in energy between two quantum states of the electron. The measurement of this energy is the basis of XRF analysis. The absorption of X-rays by a particular material varies according to the energy of the X-rays. As a rule of thumb, low energy X-rays are absorbed more than high energy photons. In order to expel an electron from one of the orbitals, the X-ray energy must exceed in the binding energy of that electron. However, if the X-ray energy is too high, then the coupling between X-ray and electron is inefficient and only a few electrons will be knocked out. As the X-ray energy reduces and approaches the electron's binding energy, so the yield of expelled electrons increases. Just below this binding energy, a drop in absorption is observed. Since the energy is not sufficient to emit electrons from that shell and is too high in energy to emit electrons from the lower energy shells. It was also observed that not all the incident X-rays result in fluorescence. The fluorescence yield in the ratio of fluorescent X-ray to incident X-rays. It should also be noted that most atoms have several electron orbitals like K, L and M shells. When X-ray energy causes electrons to transfer in and out of these shell levels, XRF peaks with varying intensities are created and will be present in the spectrum. A graphical representation of X-ray intensity peaks as a function of energy peaks. The peak energy identifies the element and the peak height or intensity is generally indicative of its respective concentration. Next, let's look at the key components of the XRF spectrometer. The primary components includes the X-ray generator, as all XRF spectrometers require a source of X-rays, and these are usually provided by an in situ X-ray generator or less frequently by a radioisotope material. Next, we have the collimator, which functions to focus the X-ray beam to a narrow diameter of several micrometers. And last, we have the detector, which detects the change in energy of the final X-ray emission and digitize it. Another thing to remember is during the analysis, the analyzer emits a directed radiation beam when the tube is energized. A reasonable effort should be made to maintain exposures to radiation as far below those limits as it is practical. This is known as the ALARA, as low as reasonably achieved principle. Three factors will help minimize your radiation exposure: time, distance, and shielding. When the radiation emitted from a portable or handheld XRF elemental analyzer is similar to the exposure received in a normal medical or dental X-ray, care must be taken to always point a handheld XRF analyzer directly to the sample and never at a person or a body part. There are a few safety tips we can remember to prevent accidents from happening when using the XRF spectrometer. Few tips like them are: radiation safety training should always be provided to the operators beforehand, and you should never aim the device at yourself or others when the primary beam, the X-ray lights, are illuminated. Also, we should remember to never hold the samples physically during analysis. Also, it should do good to be aware of primary beam indicator lights. And finally, we have to make sure that we store securely the XRF spectrometer and the samples by obeying the local storage requirements of the analysis. So, after me, Prema will continue the presentation. Thank you.
Thank you, Shri. Now, I would like to continue the presentation with the examples of the models that are currently in the market. Firstly, there are three types of XRF spectrometer: energy dispersive X-ray fluorescence, wavelength dispersive X-ray fluorescence, and total reflection X-ray fluorescence. So, here I have shown the examples of the models that are currently in the market, which is a high performance benchtop EDXRF spectrometer, high performance EDXRF elemental analyzer, followed by simultaneous WDXRF X-ray fluorescence spectrometer, determination of major and minor atomic elements, wavelength WDXRF spectrometer ZSX Primus 400, automated OAS and XRF analyzer, ZSX Primus WDXRF spectrometer, thermoscientific Niton Apollo, handheld LIPS analyzer, fully integrated energy dispersive XRF analyzer, multipurpose X-ray diffractometer, advanced WDXRF spectrometer, And finally, Super Mini 200 benchtop WDXRF spectrometer. So as you see, Super Mini 200 benchtop WDXRF spectrometer is most widely used in industries nowadays. As we go to the next part, special features. So the XRF spectrometer has these 6 types of special features. Firstly, easy load tree. It has 24 positions with XY auto changer for 51.5 easy load rings, followed by high sense technology, analytical performance based on cutting edge technology with compact size and plug and analyze installation and enhanced sensitivity and spectral resolution. With up to 4 sample masks for different sample sizes, up to 4 analyzer crystals and 2 detectors, enables fast multi-element analysis for the entire concentration range from ppm to 100%. The standardless quantitation software delivers accurate results even for totally unknown samples based on new powerful fundamental parameter algorithm which has been downloaded in the software. Followed by 5-position filter wheel. It helps to achieve better detection limits for trace elements. High sense detector technology. It covers the entire concentration range linearly in one calibration. Detector for heavy elements significantly reducing inter-element effects. Followed by sample care. Sample care, it has maximum intensity and analytical flexibility for different sample diameters. And finally, X-ray tube. The X-ray tube detects with 400 watt high sense power, and it also reduces 50% of the time measurement and double the sample throughput. Finally, we are here at the application of XRF spectrometer. At first, we would like to talk about academic. So, as for academic, just like a university student, universities and research institutions perform fundamental research on element concentration on variety of samples using WDXRF with high spectral resolution with up to 4 analyzer crystals. It covers almost the entire element range, and 5-position filter wheel help to achieve better detection limits for trace elements. As I mentioned earlier, its special feature is the biggest plus point in the application of real world. Followed by cement and building materials. Engineers are relying on the high strength, durability, and resistance of construction materials for buildings, roads, and bridges. XRF spectrometer can be used to accurately and precisely determine the elemental composition of all materials involved in cement production to check the quality control of the product towards the environmental impact. Food and feed. XRF spectrometer analyzes the mineral composition in liquid and solid food composition such as milk and growth of poultry or beef. For example, mineral concentrations are vital for every nutrition product. The quality of milk powder depends on its content such as sodium, potassium, calcium, and the absence of hazardous elements. The growth of poultry or beef depends on the right composition of mineral supplements in fodder. Glass and ceramics. The spectrometer analyzes the elemental composition of the raw materials, intermediate and final product of glass and ceramics. It can handle different sample size with changeable collimator mask in it. Collimator is one of the special features which is placed in between the sample cap. From tableware and construction materials, from industry refractory materials to high performance ceramics in electronics, non-metallic oxide materials have a wide usage. The performance of a furnace lining or a ceramic insulator strongly depends on the elemental composition. Material research. In product development, XRF spectrometer determine the purity of material properties and elemental composition with high detection power. The software enables the quick quantification of element concentration with or without prior calibration work. Metals and slags. For inspection and quality control of metals, XRF spectrometer supports with high analytical accuracy. For example, the analysis of slags in metal production is important to access actual furnace conditions, and light elements in steel production is vital for performances. Minerals and mining. XRF spectrometer determines the elemental composition of minerals and ores. This knowledge also helps to optimize the mining process and the mineral beneficiation. XRF also used to grade control the commodities such as nickel or copper ores, sand, feldspar, or limestone. Petrochemistry and fuels, which is also known as oil and gas. The analysis of additives in lubricating oil or in polymers. It is also an ideal analytical tool covering all application upstream and downstream from crude oil to final petrochemical products. For example, the sulfur concentration in ultra-low sulfur automotive fuel ULSD following the EPA Tier 3 or Euro V, which is the benchmark or the standard, is analyzed according to ASTM D2622 with WD-XRF spectrometer. Finally, pharmaceutical and chemistry. To ensure the research and product quality, raw chemicals, active pharmaceutical ingredients, and final products were analyzed particularly under strict regulations. Research and product quality are both important applications in the life sciences and pharmaceutical industry. The standardless software enables the quick monitoring of raw materials and intermediate dedicated calibration deliver precise results for quality control. As overall, XRF spectrometer, whether it's WD-XRF or ED-XRF, it analyzes the bulk chemicals of major elements and trace elements in rock, sediments, metals, fuels, and in the elements which are used in the industries. So that's it from our group. Thank you.